So on 6.3, we're gonna talk about performing function, operations, and compositions. What we're gonna focus on today is addition and subtraction of functions. That's gonna be the easiest thing, it's gonna be super simple today, it's Wednesday, we're gonna make it easy. Tomorrow, we'll talk about multiplication, division, and composition of functions.
That's a big word.
So we're just doing addition, subtraction too?
Yep. So today, when we have one function, we're gonna add it to another, or we're going to subtract it from another. And we're gonna do it in, vertical and horizontal formats. Okay? Tomorrow, we'll talk about multiplying functions together, which is basically foiling or distributing. And then we're gonna talk about dividing them, which is pretty much simplifying, because you can't necessarily divide them out. We'll simplify down as far as possible. And then we'll talk about compositions, which is plugging a function into a function. Okay, so if you have these functions, f of x is 4x to the 1/2, okay? And g of x is negative 9x to the 1/2. Okay, and in part A, it wants us to add f of x and g of x together. So, for A, I'm gonna come here and I'm gonna say 4x to the 1/2 plus, and then I have negative 9x to the 1/2. I always do this stuff in different colors, because when we do it with compositions and plug in, it's easier to see what you're doing. So feel free to use different colors on your homework, okay? Can I add those together, is the first question. Can you add those functions together?
Yeah.
Why?
Just they're both x and they both have the same thing.
They both have the same thingy, they both have the same exponent, yes.
Yes, that's the word.
Thank you, Elle. They both have the same exponent. So if they both have the same exponent and their bases are the same, I can add them together, correct? Okay, so then what do you get when you add those two functions together? What do I end up getting? You cannot do this on your
You
calculator.
get negative 5
Yep.
to is it 1 half
Negative 5,
to the 1
what's before that 1/2?
Oh, x negative 5.
Negative 5, x to the 1/2. Okay, I get negative 5x to 1/2. All this stuff that we're doing today and tomorrow you cannot do in your calculator. You do not have an advanced enough calculator. And you won't ever have an advanced enough calculator. Okay, negative 5x to the 1/2. That's where we stop, there's nothing else I can do there. Okay, that's my final solution.
Something like.
Now, on B, it says that we want to subtract f of x minus g of x. Now, let me tell you this, the order matters because you're doing operations and their functions, make sure you always put the stuff in the correct order. So I have 4x to the 1/2 minus negative 9x to the 1/2. What do you get from that? Yes, because I have a double negative, so flip, flip, ding, ding, whatever. And you get 13x to the 1/2, okay? So you're gonna have to check your signs. Now, part C says they want us to find the domains of f plus g and f minus g. Now, what's domain again?
X, a y.
X, it's how far it travels on the x-axis, right? Okay, so here's how we decide domains. We first have to take a look at the initial equations by themselves. What is the domain of f of x to the 1/2? What's the domain of that? What can I plug into x? Yeah, you could plug in a 1. What else can you plug in? What type of numbers can you plug into x? Or what type of numbers could you not plug into x? Good, Eddie, you can't plug negative numbers into this, because what is 1/2 essentially taking? the square roots. Can I have a negative in a square root function? No. So, this domain would be all positive real numbers, yes? What is this domain individually? It would also be, in this case, all positive real numbers. So when I add those together, what's the domain stay at?
Oh,
All positive real numbers. So the domain of f of x plus g of x, the domain is all positive. If I could spell, that would help. Real numbers. Okay? Because I have to take the domains of both of them, figure out what the domains of each individual piece is, and then come up with the domain of the whole thing. Okay? Because if one of the domains is more limited, then that one trumps it and it becomes the domain. Okay? And the reason that we have to do it this way is because when we end up putting it into division, it's in fraction form. And what do you know about denominators always? What can denominators not be? No? What number can never be in a denominator spot? 0. So then you have to do a little extra thinking because we have to set that equal to 0 and solve for x, blah, 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 blah. Okay? What is the domain of f of x minus g of x then? What's the domain of f of x minus g of x then? Yeah, it would still be the same thing, all positive real numbers. Okay. So, actually, we're gonna probably let us do addition, and let us do multiplication and division. We'll say compositions by themselves tomorrow. Okay, so let's do multiplication and division, because it's really not that bad. So it says let f of x equal 6x, okay? And let g of x equal x to the 3/4. F of x equals 6x. Okay, g of x equals x to the 3/4. They want us to multiply these together first. What is f of x times g of x? Okay, so if that's my first equation, then I'm going to come here and I'm gonna plug stuff in. F of x is 6x, yes? G of x is x to the 3/4, correct? Can I multiply those together? Why do you say no, Oh? Doesn't matter if they have the same exponent when you're multiplying them together. Yeah, they do. X.
Is yes the right?
I said yes is the right answer.
Okay, I'll do this.
Now, when I multiply those together, what do you end up getting?
You just get 6.
6, what?
3,
There's-
3/4.
No, not 6 to 3/4. What does this x, what is the power with that x always? 1. What do you do with powers when you are multiplying? You add them together. So you end up getting 6x. What is 1 plus 3/4? Or what is 4/4 plus 3/4? Do you guys think that way? 7/4. So you get 6x to the 7/4. Do you understand that? Okay. Part B says, let's take f of x and divide it by g of x. Okay? Which means I plug in 6x for the top, correct? And on bottom I plug in x to the 3/4. This is why we need to know rules of exponent. What do you do here? Can I do something here? Yep, you wanna make this the exponent that's 1, 4 over 4? And then you would say 6x to the 4/4 minus the 3/4 on bottom, right? And you would end up getting 6x to the 1/4. Okay? Now, the last part of this one is they want the domain of these two things. Domain of A and B. Okay, remember how over here I said, take the domain of each individual one and then we'll combine them together. Same thing happens here. What's the domain of this? Yeah, or just, yeah, how about all real numbers? Because it's not an exponent that's a fraction. So I'm not taking a root of anything. So it's just all real numbers. I can plug anything into X and get an answer out here, yes. Okay, because there's no restriction. What's the restriction here? All positive real numbers, because you would be taking the 4th root of X cubed, right? Okay, you'd be taking the 4th root of X cubed. So it's all positive real numbers, okay? So then if I put this together, if this is all real numbers, okay? But this is all, and I'm gonna say positive real numbers this way, just so I don't have to write it out. If I put those two domains together, because I multiplied them together here, what is my domain of A? All positive real numbers, because you have to take whichever one is more restricting. Does that make sense? Okay, so for A equals all positive, I can't write. A equals all positive real numbers, okay, for the domain. Now, B is a little trickier. We know up here, it's all real numbers. We know down here, it's all positive real numbers, but this is a fraction, yes? Okay, and if it is a fraction, okay, what can the domain not be? A 0. So the domain of F over G is restricted to all positive real numbers. Yes. Okay. It says, for a white rhino, the heart rate R in beats per minute and lifespan S in minutes are related to the body mass M in kilograms by these functions. So they give us two functions, yes? They want us to find those two functions multiplied together and explain what the product represents. So let's focus on multiplying those together. How would I multiply those together? What would you need to do? How would I figure that out? What? Plug stuff in first? There's nothing to put in. You see any numbers in any of that information, put in. That's why we're doing function multiplication. There is nothing to plug in this case. There are no numbers in there. There are two functions. What are you going to do? You have to multiply those functions together. So this first function is 241m to the negative 0.25. And you're multiplying it with 6 times 10 to the 6th m to the 0.2. Now, tell me, how do I multiply those together? Can I put anything together? Can I simplify anything at all to start with?
The 6x times 10 to 6.
You wanna multiply the
Uh,
6 times 10 to the 6th?
You can put it as a whole number, right?
That would be massive. I would leave it in scientific notation form for a little bit. I would not do that right away. But I would combine something else that's in exponential form. The 0.2 and the negative 0.25. What do you do when you're multiplying with powers? What do you do with the powers? Add them. So what is negative 0.25 plus 0.2? Point,
0.05.
no, you're on the right track. Negative 0.25 plus 0.2.
Is negative 0.05.
Negative 0.05,
0.05.
yeah. So you get m to the negative 0.05, yes? Now, take this number, 241, and multiply it with 6. Because I can do that, because they are being multiplied together, so it's 241 times 6. Okay, times 10 to the 6th still, right? We have that going on. Now, if I want to actually leave this in scientific notation, what do I have to do with that 1446?
Put it inside.
Yeah, which means I have to move the decimal, how many place values? 3, which does what to this? To what? 9. And that is as far as I can go. You won't be getting number answers. You're going to just leave it as it is. We might have one more example, I'm not positive, let me see. Nope, that's where we're gonna stop, because tomorrow we're gonna pick up here on compositions and functions.
Can you go back?
Yep, give me 1 second.